my name is Rob Reynolds. Welcome to Business Calculus, Chapter 2, Section 7. Today we learn implicit differentiation. And I want to kind of back up and talk to you about how we've been taking the derivative when it's in explicit form, which means it's already solved for y. So when you take the derivative of this, you get y prime, and of course, you already know, easy enough, 3 times the 4, 12x squared. Well, would it surprise you if I told you that there really was a dx out here? And what it means is you took the derivative of this x term with respect to x. So it was in terms of x, but you took the derivative with respect to x. Well, by the way, dx divided by dx just goes to a 1. So nobody ever writes that. They just say, oh, 12x squared. But I kind of want you to think about that. You took the dx, don't write it, but just think about that really was there all along. We have just never written it. So again, we're going to learn explicit differentiation, implicit differentiation, and then we're going to look at some real life situations. So once again, explicit means it's already solved for y, and you've been taking the derivative of things that look like this already. We're going to look at explore today taking the derivative of something that looks like this, and this would be very hard to solve for y. Like, so hard I'm not even sure if I could, because this looks ridiculously hard. I don't know if I could factor something. I don't even want to try. So we're going to learn how to take the derivative of something that you don't even have to spend the time to solve for y form. And again, this is explaining explicit form. I get a little bit wordy here. For those people that aren't listening to the video, at least they can read a little bit. So for our first example, it says find, now there's two ways to do this. Method A, we'll call it, and method B. So method A would say, well, easy enough. If xy equals 1, then 1 equals, y equals 1 over x, and then you can just take the derivative of this. Well, of course, that's x to the negative first, so y prime is negative x to the negative second, which is negative x squared. But if the direction said, well, don't solve for y first, and we just did the product rule right here, 1d2 plus 2d1, we would get what? 1 d2, well, the derivative of y really is dy dx, because you took the derivative of y with respect to x. If you wanted to say y prime, you can, but it's a little bit more clear if you say dy dx. Plus 2, which is the y term, and then the derivative of x is really dx dx. I'll write it dx dx, but of course you and I both know that as 1, so nobody ever writes that. But over here, oh, by the way, and take the derivative of this 1, so it's equal to the derivative of 1, which should be 0. So this is really y equals, and we'll throw this on the other side. No, wait. Can I try that? Let me back that up. Let me try it again. This is what we want to solve for, dy dx. We want to get that all by itself. So I'm going to subtract off the y from both sides and say x dy dx is equal to negative y, and then if I divide through by x, I'll have the answer. The derivative of y, which is what I was looking for, is really negative y over x. And you say, wait a minute, that's not the same answer. Well, it is if I do a little back substitution. Remember, y was really equal to 1 over x. So if I plug that in and do 1 over x divided by x, then maybe you can see, yeah, that's really 1 over x squared, the same. So you're going to say, well, this way is much harder. Why would you ever do that? Well, again, sometimes it's impossible to solve for y, and that's the method that we would use. So again, I think I have it written out there for you with the back substitution of y equals 1 over x. So remember, sometimes we have to do a little back sub when we do explicit, and it's hard to solve for y. So implicit differentiation usually means it's already solved for y, and you're taking the derivative with respect to x. Whoops. Yeah, you're taking the derivative with respect to x. So again, a little bit wordy. So, well, I don't even know if I have to go through these slides with you, but it says example number 2. So, I don't know. So the derivative of this is 6x. The derivative of part B is really 6y squared, what? dy dx, because you took the derivative of y with respect to x. Why didn't I do that over here? Well, remember, it was you took the derivative of x, and nobody ever writes that. So part C, we know the derivative of x is really just 1. Now, if you didn't want to write 1, you could write dx dx. That kind of hints to me what you need to do here. Well, the derivative of 3y is 3, but remember, you got to do dy dx. So I would say 1 plus 3. Sometimes I write dy dx as just y prime. But y prime isn't as clear as, because sometimes we have dy dt, and that means you're taking the derivative of y with respect to time, and you're going to see that we hit that in a minute when we get to real world problems. The last one, I would probably have to do the product rule. 1 d2, well, the derivative of this is 2y dy dx plus 2 d1. Instead of dx dx, I'll write 1. And then the goal, you guessed it, is to solve for this dy dx. So if you were in my class, I'd say, hey, spend a minute and see if you can't solve for dy dx. Well, you don't have to because it's not an equation, so you're not set equal to anything. So I think we're just done. Let's see if the author... did we get that for the first one? Oh, this is part B though. Yeah, I think we had that for part B. It must have. All right, so you can check out these answers on Blackboard. All right, here we go. Example number 3. Let's do it. The derivative of this guy, well, we've got both sides, so well, that's easy. The derivative of this side is just a 0, but don't forget about him. This guy is 3y squared, but you took it with respect to x, so dy dx plus 2y dy dx minus 5 dy dx's minus 2x, and I've already got equals 0. So the goal is to solve for dy dx. So I'm going to try to isolate dy dx. I'm going to throw this guy on this side and set it equal to 2x, and I'm going to factor out a dy dx and be left with 3y squared plus 2y minus 5, and you guessed it, all I have to do to solve for dy dx is to divide. So 2x divided by 3y squared plus 2y minus 5 is the derivative. And here's the worked out solutions for the author. Dividing out, and then they got the same answer. Good job. So again, this is the actual graph of this thing. It doesn't even pass the vertical line test, not even a function. We know x squared plus y squared equals r squared. Graph's a circle, so we have these relationships that are really important in math that aren't even functions, that sometimes we want to be able to find the slope of the tangent curve for at any given point. So if, for instance, if you want to find the slope of that guy that we just did at 1, -3, we would have to say, okay, every time you see an x, plug in a 1. Every time you see a y, plug in a -3. And that would give you the slope, which is 1/8, which means what? Rise 1 and run 8 at that particular point. Of course, that point keeps changing. So let's try it. Here is an ellipse. Go find me the slope at that point. So again, if you were in my class, I would say, okay, let's pause. You should have enough information to try this on your own. Print off the worksheet that's posted on Blackboard and see if you can't do that before I show you the answer. So let's try this together. Actually, hopefully you're done with it already. I'll work it out. So the derivative of x squared is just 2x dx dx plus 8y dy dx equals 0. So solving for dy dx, I would have to subtract off the 2x and divide by the 8y, and that gives me the derivative of y is -x over 4y. So now I'm going to let x equal the square root of 2 because I want to find the slope at that point. So I'm going to let x be the square root of -2, and by the way, I've got to let y be this guy. Holy crappa crappa. Okay. See, a lot of times the calculus is the easy part, and it's the algebra. Can I say divide by 4 times the y value? I just don't like these compound fractions. Let's see if this helps me a little bit. Negative square root of 2 divided by negative 4 of the square root of 2. Really? Which is negative square root of 2 times the square root of 2 over 4, which is negative 2/4, which is, oh, that turned out okay, 1/2. And it looks like the answer was given. The slope of the tangent line is 1/2. And we got that. Yeah. I hope you got that too. So here's the author's worked out solutions, and I guess that's posted on Blackboard. Let's try again. In fact, for the sake of the video and for time, I'm just going to say hopefully you can work this out. Try it. Pause the video before I give you the answer. I think the derivative will turn out to be 2x over y. Now remember, that's the same thing as just saying y prime. So if you want to evaluate y prime at this x, actually, so you might have to plug in an x and a y. So sometimes I evaluate that at the point 1, 1. So that means what? 2 times 1 over 1 is equal to just 2. I think that's I don't know if we want to spend the time to do that or not. There's some worked out solutions. It's an interesting looking function. Some application I told you about. This is kind of a trick that I'm just going to share with you, and then we'll move on to the next example pretty quickly here. But it says with respect to price. So if it's with respect to price, that's hinting to you I want the p in the denominator. So I want something like dx dp. And right now p is in the numerator because you don't want to take just the derivative of p over here. So they're hinting to you to rewrite this, and plus you don't want the derivative of this in the denominator. So I think I would multiply both sides by this black guy, this junky thing over here. So this will all cancel, and then I'd probably maybe divide by p. So I'd have all of that junk, and then over here 3 divided by p. I think the author's work, there it is, 3 divided by p. Then I would start taking the derivative. Makes it a little bit easier. It's still a terrible problem because they've got nasty little long stringy decimals. But then finally you get the derivative of x, that's the variable in the problem, with respect to p. Right? And then you could evaluate the problem. So again, it's a terrible numbers because you got to type in all those zeros, but it's really kind of a concept. So again, when you're working your homework assignment, if it doesn't tell you or restrict you to a method of showing a particular work, I would try the easiest way, and the easiest way to take the derivative is what I showed you on the very first example, solving this thing for y first. Now, you could just dive into this and do the quotient rule over here and say, oh, the derivative of this is 0. I honestly don't think that's the easiest way to work this problem. You can try it if you'd like, but I think I've done that before and it's horrible. The easiest way is to try to solve for y first. So I'm going to multiply both sides, and before I ever take the derivative, I'm just going to show you. Sometimes it's easier just to play around with this. So let's see, let's add 5y to both sides. So I think this is 6y. I'll subtract off 2x, so 1 minus 2x. Ooh, well, I don't know, maybe I should just, so y is equal to 1/6 1 minus 2x, and then maybe talk about how to take the derivative of this. But I think I made a mistake. Let's see, over here was x minus 5y, so when I subtracted off 2x minus 2x, that's no longer a 2x in there. Sorry, I think this is just an x, and I think this is just an x. Is it a positive? It's a negative x. And let's see, so, okay. Okay, I've botched this. Let me try this again. Sorry. This 1 times the quantity, I did that on purpose, and then I don't like it. So let's see. 2x plus y is equal to x minus 5y. Let's add 5y for... There we go. Oh, this is so much clearer. Minus 2x just gives me a negative x over there. Thank you. Because I had a 1. Oh my gosh. I think before I had like a 1 minus x over there. And that's, I don't know. Maybe it didn't matter because when I took the derivative, it's not going to matter. But when I divide by 6, it does matter, because I just wanted a 1/6 x. And then when you take the derivative of that, you just get negative 1/6. Oh, I made that a horrible problem. And it would have been a horrible problem if I would have tried to do the quotient rule. But it was supposed to be an easy problem, but again, my algebra stunk that time. So again, for number, oh, there's just the same problem. I don't know. I've worked it out somewhere where I didn't solve for y first, and it got horrible. This problem requires a little finesse as well. I don't know what you want to do first. I don't like that radical, so maybe my first step would be x minus 2y quantity squared. I don't know. Maybe the product rule over here. So the derivative of the first. No, wait, you do 1d2. Sorry. I keep changing how I do this, so I think I'm teaching 1d2 plus 2d1. So 1d2, the derivative of y, plus 2d1. I won't write it, but it's dx or equals 1. It's the product rule over here. So this guy, I have to do chain rule. Let's see. Derivative of the outside, write down the inside, times the derivative of the inside. Well, this guy right here is, the derivative of x is dx or 1, minus 2 dy dx. And over here is a what? 2x minus 4y. Oh. Times this guy. I want to quit right now. The goal, whenever you see a dy over here, maybe a dy, the goal is to get all the dy dx's on the same side, and I can't do that by dividing, so I think my strategy at this point might be to FOIL this out over here, multiply everything out, and then I would have some terms that I can combine. So let's see, first terms, outer terms, 4x dy dx, those are my outer. My inner is negative 4y, and then my last is plus 8y dy dx. Looks like so I only had one dy dx, now I've got two of these things. So now I'm going to try to get all the, oh my gosh, pray this doesn't happen on your test. Try to get all the dy dx's on the same side. So I'll bring them over here. I don't know why. I'm just thinking I'm going to bring them on the left side. No particular reason why I chose the left. And then if this is wrong, I'll just delete this video. Subtract off the y plus 2x minus 4y. So dy dx gets factored out. X plus 4x is 5x's minus 8y. Oh, cleaned up a little bit. Oh, I can combine over here. The negative y, and maybe I should have done that earlier, negative 5y plus 2x gets divided by 5x minus 8y. And that might be the derivative. There's probably another way to do that, but alright, so then what does it say to do? Every time, plug in a point. Oh, there it is, 4, 1. So evaluate this. Again, notation for that. Let's see if I can just back up to get rid of that box. What did we say, 4, 1? So 4, 1. So every time you see an x, plug in a 4. Every time you see a y, plug in a 1. And then tell me the slope. And I think the slope at 4, when x is 4, but of course y is going to have to be 1, is 3/12, or should reduce to like 1/4. Wonder. Yeah, oh my goodness, I've worked it out. So here I worked, oh, I would not do this. Ugh, gross, 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 gross. Yeah, I worked it through radicals. What we did was easier. My very first step, remember the problem said this? I broke that up to be this. And then ugh, gross. Gross, gross, gross. So you can see sometimes there's harder ways to work these problems. I'm not a big fan of this. But eventually we got the same answer. Yeah, nice. 3/2 or 1/4. So there's a couple more problems that you can go through. Oh, here's how the author worked it out. Ooh, they did this still gross method. I don't know. So try number 29, pause the video, And here are worked out solutions. Of course, there's PDF files of this on Blackboard as well, and then this one as well. The video is getting a little bit long, so I'll leave that for you. I hope this helps. Give me a holler if you need some help.